Our last example from section 2.5 is going to be to find the second derivative. We're going to start off finding the first derivative. We're going to find the first derivative implicitly. Once we find that first derivative, we're going to take the derivative of that to find the second derivative. So let's look at how we might proceed here. X squared plus y squared equals 25. So the first derivative is not too bad. Derivative of x squared is 2x. Derivative of y squared is 2y dy dx. And the derivative of 25 is 0. So we move the 2x to the right. We get negative 2x on the right, and then we divide by 2y. So we're solving for dy dx. The negative 2x over 2y reduces to negative x over y. So the first derivative, not too bad. Pretty easy to find the first derivative there implicitly. So what we need to do now is we need to find the second derivative. You can see that as we find the second, when we take the derivative of this derivative, we're going to have to use the quotient rule to do that. So here's how that's going to look. We're taking the derivative of our first derivative. And I'm going to take this negative sign and just bring it outside as a coefficient, so I just have to deal with the derivative of x over y. So I'm using implicit differentiation here, and I'm going to use also the quotient rule. So the derivative of x is 1 times y minus the derivative of y times x. So remember, we have f over g, so we have f prime times g minus g prime times f all over g squared. Now here I have the first derivative. Early on in the problem, I found that dy dx equals negative x over y. So I essentially have the second derivative here, but it's in terms of x, y, and the first derivative. I want to get the second derivative just in terms of x and y. So I'm going to make this substitution, dy dx, and I'm going to substitute in negative x over y. When I do that, these x's combine to make x squared. The minus the negative gives me a plus, so I'm pretty close here, except that I have this complex fraction. So I'm going to multiply through by y over y. Distribute this y here, I get y squared. When I distribute it here, it cancels this y in the denominator out, so I just have x squared. Here, y squared times y is y cubed. So this is our second derivative in terms of just x and y.